Hi everyone, my name is Einar. I've been lucky enough to be working with Anine and the people at Red Cross. And I think you're going to introduce yourself a little bit and take it from there. And I'll get back to you.
Good afternoon, everyone. My name is Anine, as Einar said. I work for the Norwegian Red Cross. Very happy to be here today to talk to you. What I want to do is, or I should say I'm a public health specialist, not a technologist. But I'm going to be talking about a project that we've been working on for the last year. So what I want to do today is share with you a very short story of our vision for how the Red Cross is using cloud technology to stop, detect, and eventually predict epidemics. We do this through this amazing community-based surveillance project. It's a story about innovation and collaboration and volunteerism. We know that information saves lives, and we also know that technology enables communication, which enables access to that information. But we didn't know how to create the solution that we needed by ourselves. We tested numerous off-the-shelf solutions, but we couldn't really make them work. They were all falling short of our needs. And what we needed was people who really knew and understood technology to work with us to find the best solutions. But let's start at the beginning. Innovation often starts with a crisis. Our crisis was the cholera outbreak in Sierra Leone back in 2012. You may have heard about cholera. Cholera is a disease causing acute diarrhea and vomiting, basically making you lose all the fluids in your body very rapidly. And if you don't replace those fluids, you can die within hours. The cholera outbreak in Sierra Leone, as you can see on the screen, it was spreading across the country in rural areas, in hard-to-reach communities with poor infrastructure and very, very limited access to healthcare. Eventually, more than 22,000 people were infected, and they needed first aid. Now, the Red Cross is pretty good at first aid. So Sierra Leone Red Cross set up first aid posts around the local communities, providing safe water mixed with sugar and salt and saving lives that way. Not only were they saving lives, but these first aid posts actually held the key to stop the entire epidemic. What everyone was wondering, responding to this outbreak, was how many are sick and where are they? How sick are they? How many are dying in which communities? Where are the caseloads increasing? Where do we need more first aid posts? Where do we need to set up cholera treatment clinics? And where do we need to respond to stop the outbreak? These were all questions that these first aid posts, the data that they had, could answer. The only problem was we couldn't access that data. The supervisors of these volunteers manning the first aid post, they were driving around on motorbikes every week, collecting the information from the first aid posts that were beautifully written in books. And then they were collecting all of those paper forms, taking them back to maybe a branch office, and then eventually ending up at the headquarters, where someone eventually, after a couple of weeks, would have the time to manually enter the data in an Excel spreadsheet. We couldn't use that data when we actually needed it. But looking back after the outbreak, when we did analyze the data, we found that most people were actually treated at the community level. Most people were successfully treated in the community and were not referred to a health clinic. Now, the problem with that is that the only data that was nationally available to guide the response was coming from the health clinics. So the information was totally skewed. Based on that, we found evidence of a huge gap in the existing surveillance system. And our innovation, the community-based surveillance, is aiming at bridging that gap. The cholera outbreak in Sierra Leone was the starting point for this because it really demonstrated the need for and the value of community-based surveillance data and what potential that has to really stop an outbreak during an epidemic. Now, we want to take it one step further because with community-based surveillance, we want to stop epidemics before they happen, not only while they're happening. to do that, we need to detect them. We need to detect these potential epidemics at the earliest possible opportunity. And the Red Cross is uniquely placed to do that because the Red Crescent movement consists of a network of 17 million volunteers in local communities across the globe. They know what is happening in their communities. If many people are falling ill, if someone dies unexpectedly, if animals start dying, when something isn't right, they know. And we just need to tap into that network to access that really high-value data in a way which is simple and low cost, and make that accessible, useful, and actionable in real time. And we think technology can enable that as long as it's fit for purpose. So about 1 year ago, I started working with Einar, trying to find a solution to this. Einar really knows technology, and he's helped us, along with a bunch of other volunteers and really brilliant people, to design a solution. Last summer, I was working in Somalia, responding to another cholera outbreak, which in 1 year affected 80,000 people and killed more than 1,100. We used an early version of the community-based surveillance system, which enabled daily and real-time reporting from clinics and first aid posts. And it helped the Red Cross and the local authorities to better target the response in an effort to stop it. When I returned from Somalia, we organized the first Codeathon, the Red Cross Codeathon, to design an even better solution. And 6 months later, we now have a functioning MVP. So to avoid another outbreak like the one in Somalia last year, we've now set up community-based surveillance in Somalia. We're piloting the MVP of the open source software that is being built. The Somali Red Crescent volunteers are reporting from their communities using SMS. They're monitoring the situation in their community and reporting if anyone is falling sick, if anyone is showing symptoms of cholera. And the Red Cross is monitoring this, looking for unusual spikes in caseloads or clusters of cases that may indicate the beginning of a new outbreak. And in collaboration with the health authorities, we can then respond early, stopping a potential epidemic before it happens. So this is the first step, getting data from communities that are off the grid, that do not have access to clinics, that do not have hospitals, electricity, smartphones, or Facebook, enabling them to monitor their own situation and simply reporting it by SMS, using tools that are fit to context. So imagine then, if all of these communities in low-income countries with weak health systems and poor surveillance get access to community-based surveillance. Firstly, using it for their own benefit, for early detection, early response, avoiding outbreaks and saving lives. But in addition to that, the aggregation of all of this insight, all of this data and information from high-risk communities, that can teach us more. How can we detect potential outbreaks even earlier? What does that pre-detection stage look like? How can we move from detection to prediction? And as the digital revolution continues to spread to low-income countries, how can we use other sources of data to triangulate our findings? Using cloud technology, big data, machine learning, what can community-based surveillance tell us that will benefit all of us and avoid even case zero, the first person infected to get sick, and prevent the potential outbreak altogether because action has been taken much earlier to stop it? So together with some of the brightest in the tech community who are volunteering to help us seize this potential, we will make information save lives. And we know that we can't do this alone. We need this collaboration across sectors, and we need tech volunteers to help us build life-saving technology. So with that, I'll invite Einar to tell you what we've actually been doing.
Hey. So this is kind of an interesting context, right? It's slightly different problems than we tend to solve. So what I want to do is walk you through the journey of this. So I'm Einar Ingebrigsten. I work for a company called Doolittle. I'm slightly committed to that company because I own it. I used to work for Microsoft, and that's how we got to know Anine and the Red Cross gang. And they came about a little bit more than a year ago and asked for help, kind of. And well, we had to start thinking about how to actually do this and build something. And together with Caroline here at Microsoft, we started kind of talking on how we can actually build this. And I want to walk you through a little bit about where we're coming from and also where what did we do and where did we get to and the architecture behind it and everything about it. And that's going to be hard because we have 50 minutes left. So at the high level, these are the things that we kind of set out to do, right? We wanted to really make software that made an impact, right? We really wanted software in the hands of the user that they could actually use, that made sense for them, that lowered the barrier for them to be able to do this. That was kind of the high-level vision of the whole thing. And also, when you're doing this in the open, we want to sort of nail these points. These are the things that we're actually doing, and people should be getting onto this project for these reasons, right? So the Red Cross had to do a big bet because they're not a technology company. They're really, they're experts in first aid, right? That's what they do. So they had to basically trust us, trust the dev, right? Would you trust yourself? No. So they had to do a few big bets based on what we were saying, right? And we were saying, well, of course, you have to do it in open source, of course. And that was a big panic moment because it's like, what does open source mean? Does it mean everyone can just go and change the code at will and just, is it really stable? Does that work? And we had to kind of go through all that and explain what actually open source means and what's the effect of it. And of course, when you're doing it in open source, you want contributions. You want to actually build a community of people contributing into this. And that was also a big bet. Would people actually go and do this? Would people volunteer and become digital volunteers? That's, another big bet, right? Because otherwise we could just be sitting there and, that's Anine and me and Caroline, we're dabbling with this. And we needed to make something that was really sustainable and maintainable over time. So it couldn't be like, cool, jazz and demo, and it works, kind of. It had to work over time. And, I'll get back to you on that. That's probably one of the hardest things, right? To actually build this and make it so that people can contribute and make it sustainable over time. So when we started off this is typically a kind of a view of all the things that you need to think about when you're making software, right? These are things that we think about. And you can't have all the developers on a project thinking about all these things. If you're doing it in, you have a kind of you need a high velocity, you need to have the sustainability and maintainability and all those things, you kind of need to start focusing on different things. So we went into, we really need to understand what we're building. That's the most key thing that we do. Of course, we have to build it, deliver it, learn from it, and rinse, repeat. Those were the kind of core principles. We wanted to fade away all those technical aspects and the different technical concerns so that not every developer coming into the project had to think about these. They should be focusing on these things. And that's not an easy task to solve. How do you actually get that done without having to think about the JavaScript framework of the week, right? Because we don't want that focus. We want to be delivering business value. So how did we do this, and how are we thinking about doing this? Well, what we have here is a failure to communicate. We had to come up with a way to understand things. So domain-driven design, anyone heard of that? Ubiquitous language. We had to figure out the ubiquitous language. So you start off with something like this. That's not very ubiquitous. It's like, if you're lucky, you might know which city it is. if you're lucky. You can make it a little bit more clear, and at least you're starting to see, well, even if you took out Oslo, you'd see that at Oslo. But a better understanding and a better ubiquitous language would be something like this. So how do you get to that? How do we get to a ubiquitous language that we actually understand, right? Something like this is actually all over the globe ubiquitous. You can look at the subway map of anything in the world and actually understand the directions of things, right? And the best way to do that is to talk to the domain experts. And if there's anything that the Red Cross has, it's really domain experts. In fact, they have 17 million of them. So park your developer side, go talk to the domain experts. And we really needed to enable that. And that's where we're getting to a little bit. I'm going to get back to that, but that's what we focused on in the beginning. Really understand the domain. And a domain is not just one domain, right? It's actually a bunch of different small things. That's what we tend to do when we build applications. We build these monoliths and think it is one domain. But it's really multiple domains. It's actually multiple bounded contexts with ubiquitous languages within these. So take e-commerce, for instance, something that most of you can probably relate to. A product is not a product. A guy sitting down in a warehouse, he's actually not talking about a product. He's talking about a box. It has a location in the warehouse, and it has some dimensions, some weight, and things like this, while the person in purchasing is just interested in what's the price of that product and how much can I sell it for, and probably not even calling it a product even. And so forth, person delivering it, also kind of a box, but just interested in the address. These are very different aspects of product. In fact, none of them are talking about product. So we need to get to those languages within the application and the different bounded contexts. And the different bounded contexts served a really big, huge difference in this project because it meant we could actually scale. We could reach the economy of scale. We could reach the place where we can actually have different teams working side by side, not having dependencies to each other, and have different velocities in those teams, which is a super important aspect. So everyone's been talking about for the last couple of years the microservice architecture of the blah, blah, blah. Well, this is what it really is about. It's about removing dependencies, about removing friction, and it's so super important. So we did this to be able to do that, to be able to actually break the software up into smaller pieces so you have autonomous teams that can actually deliver the different pieces, and then we compose it back together. We had to make quite a few decisions. Also, from a community perspective, you cannot just have, as I said, the framework of the week, the JavaScript library of the week, just be yarn add blah. You can't do that. You really have to control. There has to be some governance. You have to actually control some of these. Even though the teams are autonomous, you really don't want to have a complete chaos in an open source project. So we had to make some hard decisions. Okay, we based it off of, .NET Core. We put Angular for the front end. We did Bootstrap after a lot of coffee had been drunk and discussions. We we'll nail these. We'll go for these things. These are things that are kind of stable and people know of. So that was the technology choices. We also did a lot of other technology choices to be able to actually enable the deployment models that we wanted and so forth, and I'll get back to you on that a little bit later. Another very key aspect of actually being successful that we saw early on was we had to write documentation. Any here love writing documentation? What's even more fun than writing documentation is maintaining documentation. That's cool because things change. Or, maybe you don't change it because of the documentation. Documentation is written in stone. No. So you can't do that. So documentation was key because that's the thing that enabled people to actually get up and running fast. So you get them on to the project and they need to read something to get up and running. And I believe Caroline here worked together and getting the first start thing. For instance, one of the things that we did was to get a first starter kit kind of thing. And we iterated fast on that to get everything up and running. So how do you get up and running with the project fast? So making the software was then kind of, okay, we set the principles, we set how we're going to do things. How do we actually execute? So September 2017, we started off the first planning sessions. And we had decided on domain-driven design. We had also decided on architecture at that point, and everything is event-based. So what we did is an event storming. We went in together with the domain experts and started understanding the real state transitions in the system. So within each bounded context, we defined at this first initial workshop that we had, we defined the different bounded contexts. We started finding the different state changes in those bounded contexts. And, well, I can't show everything, but it looked, this is a very finite snapshot of something. These are events. Things that change in the system. So we tried to find all of those. And probably the learning is that all of those events that we came up with there is probably changed like 10 times after that. But yeah, we at least started understanding what is it that you're doing. And you kind of make a timeline. What you do with these things is that you start with what is the minimum thing that I need to do to actually start the system, right? So I need this to happen. And then it snowballs to the next event, to the next, to the next, to the next. And all of a sudden you have a timeline of your system. And everyone's communicating. And at the same time, we're establishing the ubiquitous language. Because all of a sudden we're understanding the domain. And these are not driven by developers. These are driven by the domain experts. They're saying, well, I need to be able to register this. So this registered, right? That was the event. So October 2017, first Codeathon. We had about 40 people that came for a weekend. Started on Friday afternoon. Ended on Sunday afternoon. And basically, I would say this is the understand part of the journey. This weekend was mostly about understanding more about what to build. So the 40 people in the room were discussing, drawing, kind of high level, talking about the problems, understanding what exactly to build. This is the happy gang that actually did it all. One of the key learnings from this whole thing is that a lot of the designers got together and started driving the project. And the way they drove the project from this was through mock-ups. So they did balsamic mock-ups that all developers, so we have actually we lost them. That's yeah. Balsamic had a system failure, and they lost all our mock-ups. But before we had that incident, this was a super helpful tool helping us communicate. So not only did we have all the events and all the drawings and the diagrams and all that, but we also had these concrete. And in an open source project, that's super helpful where people are scattered. People are occasionally connected to the project and using their spare time to do this. They're not in the same room. Having this as a communication tool proved to be one of the greatest success of the project. So February 2018, we followed up with another Codeathon. This time, we're actually building much more building. We're now in a stage of building the actual software. And of course, we're understanding even more, but building was the kind of main focus. And we had, according to this slide, 56 people come in because we did a vote. We tried to figure out what was the design principles that we wanted to focus on for the front end, right? And 56 people voted for the different things, and we came up with a tag cloud. So, in addition to all this, Red Cross started setting up these code evenings on a regular cadence, once a month. So, with the focus of actually delivering that MVP. We had kind of a date set in stone, and developers love that. We also love fixed budgets, right? And this had no budget. So that's awesome. That's really gonna... So the main purpose of these code evenings were to focus only on the coding bits, right? Get people up and running as soon as possible, fast as possible, and get them churning code so we can actually make those deadlines. And we're still running those, and I'll get back to you on when the next one is, which is going to be interesting. April 2018, we had a field test at Microsoft. So one of the partners that has helped a lot on this is Microsoft, who's been, like Caroline, got 1 day a week to actually spend on the project and dedicated time to the project. And we had a field test there to prove the software. And this is not just a, let's fire it up and see if we can register things like arbitrary. It's actually something that Anine and the people at Red Cross, they orchestrated a real field test. Like they came up with a made-up country. They had a map of the country. They had the regions in the country. They had all kind of metadata associated with the country. And they basically set up field hospitals and everything, and it felt real, right? So it's a kind of a closest thing to real as we could get to the real world, which is where we went next. So the next step of the field test, the second generation, version 2 of field test, is actually in Myanmar, running this and trying it out. And as you can see, the field is messy. So that's the IT department. That's a lot of wires. It's just, how do you get stuff working out there? It's quite challenging. So going from there to May, we actually put everything in production. And we were talking a little bit earlier, and this is the learning part. The words matter. So Red Cross said, yeah, it's a pilot. I translated it into pilot, yeah, it's 10 users. That actually meant production. So it's way more than 10 users. And it's actually running now in Somalia. And the picture there is from the training. Those are people at training, learning how to use the system. So we made it. Actually, a year ago, I was on this stage talking about it, and a year later, we're actually out in production. So that's pretty cool, I think. So community, you've heard community, and that's the reason this is possible to actually do. The community is headed up by a core team. That was one of the core fundamentals that we wanted to establish very early on, that we had a core team of kind of stable people that were committed to the project. They're not necessarily going to be on every meeting, but at least they're a kind of a stable flock of people that you can reach out to and get answers, and would be having kind of different tasks they were focused on. And ever since February, I believe, it's been every week. We started off with like once a month and increased everything up to once a week, which also makes sense when you look at not everyone can actually join every time, right? We live busy lives, and this is what we do on our spare time, right? So we needed to step that up. This has been a great experience, I think. I know I've been guilty not being there all the time, but at least when I am there, it's like awesome, because we really get to get the communication going and understand where to move next. And since we do have different aspects that we're keeping track of and focused on, you get to learn a lot what's been happening, right? So the next thing is, well, we actually managed to build a community around the software, which is what we set out to do. So there's 55 contributors, there's 60 forks of the project, and this is an increasing number every day, so it's about 2,000 plus commits. And that kind of speaks a lot to how we've actually managed to get people interested in it. And I would say, who's here, who has actually contributed here in the room? So We have 2 more? No? Well, thank you. But in general, thank you to the community out there who's been actually working hard on doing this, showing up on the Codeathons, code evenings. We had a guy, was it in Texas? Where was it? I think it was Texas. Yeah, Texas, who was kind enough to test the Getting Started guide and contributing back and really getting everything up and running. So really huge. There's the camera. Hi, camera. Thank you to the community for actually contributing to this, because you're the guys that actually made this happen, right? So we've been talking for 30 minutes. I'm not going to open Visual Studio, but I think this is developers conference, right? So we need to move on and talk about tech, right? And the result before that. So this is what we made. This is the software running. It's been censored. I have cut away data because it's you're not supposed to see that. So this is just a high-level kind of the different bounded contexts, as we spoke about, that we have. We have project administration is very different from user management, which is very different from volunteer reporting. There are 3 different bounded contexts, and we've composed it all back together. And as you can see, in this, in the project administration, you can register the different health risks, like cholera and different things, and different aspects and details about the health risk that you need to be looking for. And then you register these data collectors. The data collectors are the ones actually sending in SMS, and that we will see in volunteer reporting. We will see the result of those. And the case reports. Again, it kind of looks a little bit boring when I cut out all the data, but at least it's showing the software as is. We had to do SMS. Again, this is IT department. Where is this again? Is this Myanmar? So that's how it looks in the field. That's the box we had to set up. SMS was a super hard problem to solve, believe it or not, because you cannot go for like Twilio or any of these services and just get it running. It won't work in these countries. They don't have agreements with any telecom operators there. So we basically had to put hardware out there. We started off with this box, which is basically, it's a fancy Raspberry Pi with an SMS thing, a 4G on top, right? Mobile, not 4G, sorry. Yeah. My bad, no 4G. No. There's just a mobile thing on it, a cellular thing. Actually, it says 4G on the box, but no. Or I said 3G, but not even that. So it's just SMS. But it's kind of cool because it had a failover thing. So you could put 2 SIM cards in it, and it would fail over. And 2 antennas, and was reliable. It was built for reliability to be put out in the field like this. Later, we've also done a test with a Cisco box that does the same thing, a much more rugged device that would probably, be a little bit more reliable than a Raspberry Pi. But, yeah, who knows? Maybe the Raspberry Pi is much more reliable. Who knows? We don't know. So we're doing some testing with that as well. But this is a hard problem to solve, and the SMS thing is actually connected to the cloud via Ethernet at this point. We could also do Wi-Fi, but it's at least connected to the Ethernet right now. So how do we do this architecturally? How did we build it? I mentioned something about events and domain-driven design and all these things. So let's start off with the core principles. And you've probably heard about CQRS. That's at the core, right? We actually split the reads from the writes. So we start off with that. We start off as a core principle of everything that we do. We're thinking single responsibility, separation of concerns, and all these things, leading us down the path of CQRS. We're really splitting up these models. So that's at the very core of everything. We had different bounded contexts, And these are the microservices. This is how we define the microservices, right? Every bounded context is a autonomous thing. It's the deployable unit. That's what you deploy together, and it's an end-to-end. You deploy the data with it. You deploy the back end, the front end, and whatever. So everything that goes together is deployed together, and that's our boundary for the service. We then have an event store. We're saving everything in an event store. And we have a messaging infrastructure to be able to communicate between the different bounded contexts. We don't take dependencies between these directly through APIs. We actually have a convention system for events that gets automatically picked up as long as it matches. And that's how we kind of decouple everything. So the events doesn't even have to be exactly the same, but it matches on properties. And I'll get back to, I'm getting back to you a lot, right? You see a pattern here? Oh. So these are kind of the core building blocks or thinking going into it. And with events, you get a lot of benefits. You get to actually collect the actual time series of the state transitions of your system, which enables us to actually dive into everything that's going on and see all the details, and this is the thing that we can actually do the machine learning on as well. Machine learning tends to only look at, well, it's traditionally being used for things like IoT and things like that, where it's a time series. It's time series events. But since we're capturing everything as events, we get a lot of context. Context that you normally had to do correlation and data in machine learning to actually get. But we have everything as events and is stored permanently, forever and ever. So GDPR, anyone? Audit trail? We have it. So this is kind of one of the biggest advantages that we have with events, that we can actually start making sense of what's actually going on, rather than looking at a data table. Yeah, I didn't know what happened to actually reach the conclusion. We now have everything, and we can go and see why the conclusion is as it is. So translated into what we just saw. So we had the different bounded contexts, and we have admin as one, or kind of project management thing. We had the user management and volunteer reporting, just sitting side by side, not knowing about each other at all, and just communicating through events, basically. So looking into every bounded context, as I said, we had to make some hard technical decisions. We went with Angular with TypeScript for the front end. We have .NET Core and C# for the back end. And we have a MongoDB. Everything is just documents sitting there. And, well, events being published out. One of the interesting aspects of such a project is that the scale of things, right? When you're doing this kind of thing and you're saying a deployment is end-to-end like that, and Red Cross is in how many 190-something countries?
91.
91. What if you go and want to scale out this, and you want to do a multi-tenancy? We don't want to have all those tenants in one database. In fact, we're not allowed. For data security reasons, we have to have complete segregation. So if you see, we have 3 bounded contexts, and we're saying that every tenant has a database, and every bounded context have a database. You reach a vast number of databases. So we need to automatically provision these things, right? Because all of a sudden we are looking at like hundreds of databases that sit there. Hundreds of event stores that sit there. All of these things that needs to be automatically provisioned and just be there for you. That's also part of this problem that we're solving. From the front-end perspective, everything is just working with commands. So the user has an intent, and the intent is expressed as a command. It gets validated, authorized, all these things, talks to an event source. This is an event-sourced system that generates an event. And these are the things that we're storing to the infrastructure plus publishing for an event processor or multiple to deal with. So that's kind of the cycle there. And if you look at the different pipelines that we have in place, these are the 2 different pipelines. working there. I'm not going to go too deep on this, but this is kind of the core thing that sits underneath. Is called Doolittle, that logo thing. And that's the pipeline of Doolittle. Pipelines. So getting back to the cross-communication between bounded contexts, one of the things that we came up with was a concept of a mediator. A mediator is basically responsible for knowing about the different bounded contexts that it's communicating with, right? Without the bounded context actually knowing about that itself. The mediator knows. And the mediator knows to translate the events into something that the other bounded context knows about, right? And it also knows how to deal with, if you have an event source systems, events change characteristics over time. And we call that generations. How do you deal with that? Well, the mediator knows what kind of dependencies are out there. And it knows how to translate. Basically, you tell it how to go between the different generations by translating, well, mapping from one generation to another of a particular event. And the mediator then knows all of this. And it knows all about the different dependencies and is able then to translate into the correct ones, sending it to the correct place, right? So that's the responsibility of the mediator that we have. And looking at the runtime environment, we went through a lot of testing of different things, but at the core, we have everything is running in Azure on Azure Kubernetes, Managed Kubernetes, the AKS. And on top of that, we've been dabbling with a lot of different technologies to actually try and see what actually works. And we have different concerns because we need to be able to log things. How do we collect all the logs in a distributed system? Well, you install a Fluent daemon and you start sending the results from all the nodes to somewhere. But you need to start putting in things like correlation ID because it's a distributed system and there's well, how can I actually track something throughout the system? It starts off with a command and ends up with an event on a different node. How can you track these? So you need to put in things like correlation ID, and we basically log everything as JSON, and we use Fluent to actually put that forward. And we've made some interesting discoveries with Elasticsearch and how it does not work in reality, and basically thrown that one out the window. But interestingly enough, one of the things that we looked at when it comes to the interbounded context communication thing is how can we reliably do that? And we've been running, actually the production environment is today running on Kafka. And in fact, Kafka is our event store right now. We've set the, what's it called, retention plan to be forever until we introduce the new event store, right? So it's actually keeping everything in Kafka, and we're also using it for interbounded context communication for the time being with different topics and something sitting on top telling the different Kubernetes pods which topics to subscribe to and which topics to send to. So that's kind of moving away because we're now looking at gRPC and Istio as the thing. So gRPC will be the thing that communicates between the different bounded contexts, and Istio providing reliability as it supports gRPC out of the box. So that's kind of the high-level view of the runtime environment that we have. So, did we learn anything? Nah, nothing. I'm done. No. Well, yeah, we did learn something. We did some discoveries. We learned more about external events, and we are not going to call it external events, but until we come up with a better name, there's something to be said for events that lives in another place, right? So you need to kind of know about these events living in a different bounded context. And what we're looking at is formalizing this in a much better thing rather than what we already have now with the convention system and all that, but an automatic system that actually packages those events as NuGet packages, for instance, for a .NET application where you can go and just subscribe to a NuGet feed and it would be versioned. You would be having all the metadata of the version sitting in the package, and you could just take a dependency to the package from the other bounded context, right? And the mediator would then automatically just know your dependencies like that. So that's something that's coming out of this as learning. We also discovered something, and I think that was a little bit by accident, but it kind of evolved with the community in the room and all the people in the room. We had the event boarding. All of a sudden, I can't even remember who came up with it. Maybe it was you, Björn. Yes, Björn. You actually started, what if we visualized these dependencies in a good way? And that's something that we actually put in for, it's on GitHub as one of the projects. We have an event board with just swim lanes with the different events available in the different bounded contexts, and you can just go there and say, oh, I need that one, right? What if you can create tooling around that to actually make that more visible so you can see the different dependencies? That's the kind of next level of that. We discovered more. We found events to be super useful. We also discovered that, well, actually, developers really want to help, right? That's really cool. It's really, really fulfilling to be on a project like this and see people just show up and wanting to help. That's exactly what we wanted to do. What we set out to do was happening. The core team thing really worked. I really enjoy that thing. It's a consistent thing, and 8:30 Wednesday, I can just go to this Skype place, and there will be people. Might be just 1 or 10. Somewhere in between, right? But at least there's people to talk to about the project. It's really, really cool. The mock-ups, as I talked about, super, super useful. I know I've been using that kind of throughout my career in the last 20 years or more. I'm old. Scary. Mock-ups has always been helpful, but it's kind of just, it's something we do. And we look at it as like, yeah, we'll make something else. But this turned out to be, that's what we're going to build. And the designers has been super, shout out to Alexander, to actually help us get that right. That's been so super useful. Taking away those technical concerns, remember the slide with all the things on it? Taking away those things. I know it's painful. As a developer, you really want to get in there, get deep, get control. But it's so useful when we get people to focus on the business value and delivering that. Of course, you might have opinions on whether or not this is a good approach or bad approach. But if we just say, well, we're not going to discuss that now at the Codeathon, but please come and talk to us and raise your concern, and we'll talk about it definitely. But at the Codeathons and the code evenings, let's just focus on business value. That really gets us going, right? And gets us focused. We've proven that it is possible to scale. The Codeathons itself has shown that we are able to scale and divide everything up into teams and have these kind of things going on, like we had the event board and all these things that were helping us to make that possible to scale. And the best part of it all was Caroline's duck jokes, consistently throughout everything that we do, even on the core team meetings. Yeah. So that's keeping the spirit up, right? That's super important. So there are things that can be improved. And funnily enough, you'll see events on both these. Because most systems are not event-sourced. And I don't know, how many here has built event-sourced systems? Yeah, so a few. About 15% maybe, right? So it's unfamiliar to a lot of people. And that becomes a friction point when we're saying everything is events. In fact, there's nothing else but events. That's the only thing that you can do. It's like, okay, what is an event? It's awesome. Yeah, so it's been a hard thing. It's been a friction point because it's also kind of there's no real answer to it. What is an event? How does it look like? What's the characteristics of an event? What's a good event? What's a bad event? Well, at least it's not create, update, delete events. So no CRUD events. That's the only thing that we can kind of just rule out those. But that's been one of the biggest things. So documentation, yeah, it's already dated. So maintainability of documentation has been hard. And something that we really, really need to step up because we're approaching a new Codeathons and we need to really get these things in place. And that also goes for better samples. So we started off with a sample and it was totally unrelated. It was like an e-commerce thing. That's my go-to thing. Yeah, whenever I want to do something and I want to explain something, e-commerce. Whew. Must be because I worked with e-commerce for some years. So that's not a good sample, so we need a better sample, something that is more real and related to this, and more of them. Stable deployment, that's been a bit of a friction point. We had it, and it went away, came back. So it's like, can I trust this? I don't know. So and that needs to be improved a lot, and that goes hand in hand with kind of technical uncertainties as well, because since there's a lot of new things, there's a lot of technical uncertainties that we just haven't really dealt with in a good way. So we need to really make those go away. And when you're putting things into a distributed system like this and don't have access to logs, hard to find bugs, turns out. I don't know why. And we have a massive bus factor. And the bus factor is somewhat spread out on me, which has proved to be a bit of a problem. When I have stressful times at work, nothing gets done on the infrastructure piece, which is not a good situation to be in. And I think that goes a little bit for other aspects as well. So in general, bus factors, depending on one person, and especially on an open project like this, it's not a good idea. So that's something that we really need to learn from and make better. And sometimes it's just making better documentation, right? Sometimes it's just documenting how do I get to the logs, right? Okay, use Kale. Yeah, what's Kale? Well, you download it here. Yeah, I could have done that in writing, right? So that's something to improve on. So the future of this, where are we going? Well, we're just continuing development. We're just going to carry on developing. And the next thing is going to be the next code evening. It's next week, is it? Yeah, 20th. That's time, place, I forgot.
4 p.m. Norwegian Red Cross building.
4 p.m. Norwegian Red Cross building. And if you find this interesting, please come. Please come. And it's not just about development. In the rooms we've had so far, there's been developers, we've had product managers, we've had designers, we've had UX, UI, all types of people. Anything that you can do, basically, to help. Sometimes we're like product management and just getting things structured is super good, right? There's another Codeathon, version 3. That's on September 27th, in the middle of that Oslo Innovation Week. And please, if you find this interesting again, just show up and we'll get you up and running. I see I'm very good on time. I actually have some more time. We have some resources for you. So obviously there's more to read on the Red Cross official pages, and the GitHub page has everything. We have all the documentation that we do have sitting there, all the code, of course. So that's probably the most important thing for you developers to actually go to. And Microsoft, there's been a lot of attention inside Microsoft on this, and Microsoft is helping a lot, not only with Caroline, but also other resources helping out. And also they're providing Azure for this project, and in general, just been awesome at helping us out. And they did a write-up of the whole project. If you want to learn more about the underlying architecture, you can go to doolittle.io. And again, documentation is a thing, I've heard, and it can be improved. If you have any questions, please don't hesitate to contact us by email. And actually, Anine, if anyone has any questions right now, we do have 5 minutes and 40 seconds.
Hi. I was just wondering, could you say something about how this system is used day to day, both by volunteers who report, but also Red Cross personnel, like sort of how's the data monitored, how are decisions made about what actions to perform?
Absolutely. I can repeat the question. So the question was, how's this being used on a day-to-day basis, both from a volunteer reporting something and someone looking at the data and actually taking action?
So at the moment, we have about 75 volunteers in Somalia who are monitoring their communities and reporting whenever they see something which is causing concern in that community. They're reporting when they see something, meaning it could be every day or once every 2 weeks or never, because everything's fine. And then because we're currently at MVP, we don't really have any analytics features in place. We don't have any data visualization yet. So what the Red Cross is doing in Somalia is going to the website, exporting the data, running it on Power BI or just using Excel and doing their analysis and following up with the volunteers.
Yeah.
Other questions?
Yeah.
You mentioned that elk or Elasticsearch didn't work for you. What were the reasons?
The question was, why didn't elk work for us? I don't like things that crash and burn. And it crashed and burned consistently. Even it crashed in a way I've never seen anything crash before. And ingesting things into it, all of a sudden the thread in the Java code died, and it pretended to be alive. So Kubernetes didn't know that it was live. So we had to basically have you can get it to be reliable because by setting something in Kubernetes where you ping the whole thing and then restart it. But I just, no, get out of my way. There are better services out there. So that's me being frank, sorry. So, yes?
There's a lot of health organizations, non-profits, and it seems like they work in silos. So there's no collaboration across. So I'm thinking about the Medics Without Borders. They obviously would be interested or should have an interest in something like this as well. Have you thought about collaborating with them? And if so, how would such a collaboration be?
Excellent question.
Should we rephrase the question?
Please do.
Yes. So the question was, how do you break down barriers between NGOs, right? Help these different organizations, and how can they? Well, what's your perspective on learning from them, and can we get the software out to them, maybe?
So for me, this is one of the reasons we're doing it in the open source. So we want the software to be available for anyone who wants to use it. First and foremost, our priority is the Red Cross movement, 191 national societies that need access to this system, and we support them in rolling it out and utilizing it. We've looked at so many different software solutions, especially for data collection. We find that most of them are app-based, so an app on a smartphone. And the communities we work in don't work well with that, because we work in the most hard-to-reach areas where there's no infrastructure, there's no electricity. Typically, there's not even a very good mobile signal, so you might have to walk up the nearest hill to get signal, send your text message, and then you come back to your village. If there's no electricity, you need to pay someone to charge your phone, through a generator. And if you need to do that every single day, we're not going to be able to maintain the system. But these old feature phones, their battery lasts for a week, right? So these are some of them. And what we've found is that there is no good SMS-based system developed. We've tried, and we haven't found anything. So we made a decision to build it ourselves. And of course, we want to make it available for anyone who could utilize it.
Yes.
There's something called not invented here syndrome. You think that's going to be an issue as well? So like, let's say there was another organization making it for Red Cross, and then the Red Cross makes it like with a partner, but then that's, it's a concern or issue. There's a lot of like, I would say, politics in these organizations that are like, so you don't focus on like the actual thing you're trying to do to help and the most efficient way of getting there. It's kind of because to some degree you're competing, right, with the other organizations for donation money and whatnot.
Yeah, so the not invented here syndrome, that's what I heard. No. So, politics involved in not invented here, and between the different organizations. What?
I think in many ways you're touching upon something which is kind of right, and maybe more so from the outside, it looks like we're competing for funds and we're competing to get there first. At the end of the day, we all have the same objective. And so if someone else had developed a solution that we could use, I wouldn't spend the last year going through everything that we've done now, and I see that we're going to continue working on this for the next 3 years. I'm having a lot of fun doing it, but if the system was already there, I wouldn't have taken the trouble. What we want to do is to target response and stop epidemics from happening, not really build software. Sorry.
I guess there's tons of organizations like Code for Good and whatnot that are all having these kind of objectives. We have this 17 Sustainable Development Goals and whatnot. But the amount of overhead to manage all of this and to kind of like take this big thing here and then break it down to kind of microcasts and distribute it and then put it back together again. That's an enormous kind of job. But again, the community can also do that. Have you thought about like instead of just doing codeathons, but also getting people together on the whole overhead thing, so that you can do more or do bigger and faster?
So the question is still on coordination, collaboration, and working together with other partners trying to do the same thing. I would love to get there. I think what we have been doing is, starting small and growing quite organically. We've been prototyping and piloting for the last 3 years. And then last year, we started building ourselves. Now, we need to figure out our own house, our own documentation, our own way of working, how this can be a scalable model. And we want to invite other people in, partners, organizations. We're in close collaboration. So Norwegian Red Cross is leading this project on behalf of the Red Cross movement. So collaboration with our secretariat in Geneva. We're in close collaboration with WHO, with the Norwegian Institute for Public Health, really working together on the health technical side. And we want to make this, if people can organize codeathons or code evenings in Somalia or in Senegal, that would be fantastic, and contribute into the same project and really make it into a solution that anyone could use, regardless whether you're Red Cross or mobile medic or,
Yes.
Have you thought about doing something, so up in Trondheim there's something called Flare. So it's an app and you can alert if there's some emergency right here. So they're doing like high level techie stuff which has been perfected in terms of battery usage and whatnot. So if you can like make a bridge between industrialized countries and then developing countries, and so that here you use SMS and here you use app, and then somehow try to build a bridge so that they meet in the future, because obviously they're not going to stick to SMS forever, and then if you in parallel you do some fancy stuff in Norway, you can find a way to collaborate where you meet on that kind of the overarching sustainability or emergency goal. that something you thought about?
Do you want to try and answer that?
No.
So that's probably a discussion you can follow up.
Yeah. Yeah, it's a bigger discussion. Yeah, I think so.
And our time is out.
Our time is out. 0:00. Okay. Thank you, everyone.
Thanks very much.